So on this particular problem, um, we got 3D. That's the first thing that you got to recognize that when I put the word cross sections in there, I'm alerting you that we're talking about a 3D shape. It also says the word solid. That's another reason why you know it's got to be 3D. Can't have a solid thing that's only two dimensions. So what I want you to do first every single time is graph the base. And in this particular situation, you've got an ellipse. It's an oval shape, looks like this, where the edges, the top edge will be at 5, bottom edge -5, 2, and -2. Exactly. This one will be a Y major because you've got the 5, which is bigger than the 2. That's a hyperbole. You don't need to worry about that for tomorrow. I will give you a formula for the shape. Right. This time, because you don't, most of you aren't going to recognize that it's an ellipse. I'm telling you that's what the shape is supposed to look like if you're going to graph it out. I probably won't give you a formula like this tomorrow. I won't give you an ellipse. I would probably give you something like this and say, graph this. Use this thing as your base and say it's bounded in the first quadrant or something like that. It could. Yeah, it could look like Sydney eyebrows. But for this one, the important thing that you need to do now is not even worry about the 3D shape. I just need you to talk to me about the cross sections. And the cross sections on this particular shape, they're going to be squares. And the base is really important. What I would do if I was setting this up, I've drawn out the base. I would mark where the base is going to show up in this actual shape. So if I'm talking about the base of the square, I need to recognize that it's this spot on the actual ellipse. Not just the top half, but also the bottom half of that ellipse. That would be the base of each square. It's the whole thing. It could maximum we could be talking about a width of 10. Minimally is going to be 0, but to account for all of the variability from the beginning to the end, that's why we're going to use an integral. What the integral actually does is it says you have a whole bunch of these three-dimensional boxes that you're going to line up so that eventually you have something that becomes more like a bookshelf. It'll look like that once you stack all of these boxes next to each other. And that's why it's a solid shape. For right now, though, the problem is you need to make sure that you have a formula to use or a number to use for that base. The cross section is a square, so we know it's going to be base. And this is also going to be a base right there, right? What's the formula that you're going to use to find this base? Yeah, I agree with that. I'll go ahead and give you b squared. I have no problem with that. I'll even give you these boundaries are 2 and -2. My problem is I don't have a dB or a dx. I don't know what variable or what is actually supposed to go in that spot. I want to use that. Solve it for y. Okay, I got you. Let me go ahead and fill in this part real quick. That's what I get. There's a couple extra pieces of information that are in here that I want to talk to you about for a second. And the first piece of extra information is why is there a 2? There's this 2 because when that we drew out that original ellipse, the square root would only account for the top part. And when you square root something, you get a positive and a negative, right? So the positive square root, since that's all we did when we solved it, only talks about that blue line that I just drew in. I need to account for the top and the bottom section. That's why there's two of them. Your question, Edo, a second ago was why do we use -2 and +2 for the boundaries? Those are my x coordinates. That's how far sideways it stretches. X is independent. It's controlled by the graph only. The y variable is controlled by this formula. So that's why we want to use x's for our boundaries, is because it's independent. It also matches our dx here. The reason why it's squared is because we use b squared, the base times the base. So if I changed it from being a square, there'll be a different formula. If I want to say it's straw triangles, it would be 1/2 base times height. Or if I want to say they were rectangles where the height was 3 times the size of the base, it would be b times 3b. If it was rectangles where the base is 3 times or smaller. From here, all you do is your antiderivative, plug in your boundaries, and then you're done. You want to go through the antiderivative of this one? This one's actually a lot easier than what you think because that squared is going to cancel out the square root. So this is a basic power rule question in actuality. The basic power rule says that the 2/4 is going to cancel out. I end up with 1/4 of 100 minus 25x squared for my integral when I just simplified just what I had on the inside. So I did the square. I reduced the 2/4 to begin with. Yep. So I actually used that square already. From here, I'm going to take that 1/4 and put it on the outside just because I don't want to deal with it until afterwards. It makes me feel more comfortable. Angela, you were talking about that the other day during class. Power rule says increase your power by 1. Put that same thing on the bottom of your fraction. So I get 100x minus 25/3, x to the third. The plus c, we have it for right now, but we know it's actually going to cancel out. We know it's going to cancel out because this is a definite integral. I don't remember if you lose all the credit or if they just don't give you an extra point. It's kind of scary to think that you would lose like 3 points on the AP from not writing C. But I didn't write the AP, and I'm slightly less shady than they are. Fair. Fair. No, it's slightly. I am writing your test for tomorrow still. From here, you just plug in your 2, and then you're good to go. You get 200 minus some numbers. I don't know what they are off the top of my head.
You're plugging in 2 first, both of them, so 200 minus 25,
Mm-hmm.
the minus.
Yep. I think this is justifiable by hand. Once you get to here, you're done. You don't actually have to go any farther than that. You don't. Because technically that is a numerical value that satisfies the equation. They just want you to get rid of all the like messiness around it. So really the big idea on this one, step by step, I would draw the base. After that, I would draw the cross section. Once we had the base and the cross section, we identified the base inside of the cross section. So that's relating those two pictures that you've already drawn in steps 1 and 2. Step 4 would be to find the area of each cross section and then finally integrate your answer from step 4 into the boundaries for x.
Want to draw it out, so say like the cross sections were squares,
Mhm.
we're doing squares. Then identify your boundaries and then like, plug back into your integral, like the
Mhm.
problem.
Yep.
So it's just then across those boundaries.
Yep.
Okay, but then you square it
Because it's b squared. Yep. So one of the extensions I could ask you for your test, hint, hint, wink, wink, if you're paying attention right now, I would say something like find the area between these two curves and now apply a cross section to it, which would be top minus bottom. So I could do all kinds of different shapes for the base if I wanted to. I can make it look like a canine tooth. I can make it look like a cornucopia. I can make these things look like cylinders with like the middle cut out of it. I could have you do like a 3-dimensional basketball court if I wanted to. But the idea is once you find that base, you're just going to use that integral. You're going to use that height that's in between your top and bottom curves over and over and over again. The integral makes it so that you're doing that same shape over and over and over again without actually writing out the work for it. You would get a function because I'm going to leave the x's in it. If I said, hey, tell me the base of this shape is defined by x, the square root of x minus 2/3 x, that would be the base, and that would also be the function that you use inside of your formula at the end. I'll show you one in a second. Oh yeah. Oh, we need the luck. We need all of the luck. We need all of the luck right now. You do.
That's not true. You wish me good luck on my last test or my. You retract what you said about you have to be an idiot to get a.
Well, this is an example of what I meant by that. So if I'm giving you a curve that's on the top, the red one, and the green one that's on the bottom, you would tell me if I said something like the cross sections are rectangles where the height is 3 times the base. Yeah, I'm still recording, so I only got a minute. So I'm gonna talk through it real quick. Yeah, I've been listening to you the whole time. All of your classmates have been hearing all the terrible things. That did happen. All right, here's what I'm saying. This would be your base because I'm talking about a cross-sectional area. This is the B, okay? Your formula would include that. Those two yellow lines correspond to each other. If this is little or big B, this will be 3B. So my integral is B times 3B from -2 to +2. I would have needed to give you a formula for each one of those red lines. So if I wanted to just make one up real quick, x squared plus 4 minus 1/2 x minus 2